All right, this is lesson 7, and we have a really cool problem for you, but that's only because I'm a basketball fan. Okay, a high school basketball coach wants to keep statistics on 25 players on his team.
Heads up.
I never understood heads up, because shouldn't it be heads down? Anyway, to do this, he times each player as they run a specific distance. How can he calculate how fast each player is running? Now, what we could do is we could just do 25 separate problems and we could solve for the variable, because we do know that distance equals rate times time, and we could take each kid, because we know their distance and we know their rate, and kind of calculate their time. But that would take a long time for 25 players. So there must be an easier way to do that. So before we talk about how to do that, I want to discuss the next slide. Okay, we want to define a literal equation. A literal equation is when you solve for one variable in terms of another. So for instance, if I want to solve this for time, I could just very quickly go, well, since rate is attached to time by multiplication, I could just divide by rate, and whatever I did in one side of the equation, I did the other to keep it in balance, and I get distance divided by rate will give me the time. And I could calculate time for each runner on his team. So that's one thing I can do. But this is called solving for t in terms of d and r. Okay? And what we just did is we solved a literal equation. We solved for one variable in terms of other variables. And it's solved for t because t is alone on one side. So let's look at some of the examples on this slide where it says y equals 2x plus 3. Well, that's solved for y in terms of x. Y is alone on one side. X equals y minus 2z. That's solved for x in terms of y and z. But look at the next one, y minus 2x minus 3 equals 0. That's not solved for any variable because all the variables are on one side. In fact, everything's on one side and 0's on the other. So that's not solved for any variable. This one says x equals 6 minus x. Even though it looks like we're solved for x here, we're truly not because there's an x on this side. So the variable you're solving for must be alone on one side and everything else on the other. So that's what makes it solve for a particular variable. Now, we have some helpful hints for you that is in your workbook and is also on the slide. You have to think of the variable you're solving for as the only variable in the problem. Think of everything else as a constant. Always try to get the variable you're solving for on one side by itself. And if the variable is on both sides of the equation, we're going to start by using that variable first. And that's my decision. I mean, you can do it other ways. And there's another helpful hint there that says if the variable you're solving for is the only one, is already on one side and it's not on the other side at all, then just leave it there. Don't touch it because we want it solved for that variable. Okay, so let's do some problems. Okay, as we revisit the challenge problem for a second, so if this coach wanted to keep track of the time for each of his players, what he could do is we could solve this for time, this equation like we did, and then for every kid, what he could do is just plug in the distance and divide it by rate, and that's much quicker than to take each kid and do the following. If he didn't do this, what he would have to do is he would have to go, well, distance equals rate times time. So for Johnny, I could plug in his distance, I could plug in his rate, and then I'd have to do division every single time for every individual kid. That's a little hard to do. So it makes sense a lot to solve literal equations. There's another example for you that there's a lot of places in which, and you might know about this, where they mark an X on the road, and then they mark another X on the road. And what they do is there's a helicopter, cop in a helicopter above you, and what he's doing is he times you. And he times you, and what he does, he already knows this distance. Okay, now remember, a second ago, we just solved this for time. I'm just going to show you. Now I want to solve this for rate. Watch why. If I solve this for rate, I can divide by time, and I get distance over time equals rate. So the cop already knows the distance because they put the x's up. Okay, they time you from one x to the other, and now they can get your rate of speed, and they can see if you're speeding. And if they see if you're speeding, because all I did was take your distance, divide it by time, they see if you're speeding, and then they call a patrol car ahead of you and say, hey, get that RAV4, because he's going 90 miles an hour, okay, in a 50. So that's kind of cool. So it's too bad that cops know math, but that's what happens. So that's one way they can get you. So their literal equations are used in real life all the time. But before we do some other problems, I want to show you a problem like this. In a problem like this, it's important to know if these things are equivalent, because sometimes when you solve a literal equation, two people can get answers that don't exactly look the same, but they may really be the same. So let's take a look at this. We want to see if these are equal. Okay, first thing you need to understand is that this starts with 7x minus 6 over 3. This 3 is over both of these terms, so it means that this 3 is for both of them. So it means that the 7x is over 3 minus the 6 is also over 3. That's what that really means if you think about it. Because when you combine fractions, you combine the numerators, 7x minus 6. I can't really combine them, so I would just get that, over 3. So this is really 7x over 3 minus 2. We could write it like that if we want, which is not equivalent to this. You cannot just take the 3, take the 6 and divide it by the 3, because this 3 is also for the 7x. Okay, so these are not equivalent. Okay, so the first example, they're not equivalent. Let's look at the second example. And it'll take me a second to write it right down. Let's get this distance problem out of here. Okay. The second one was y equals 7x minus 6 over 3, and y equals 6 minus 7x over negative 3. Okay. Taking a look at this, I'm going to rewrite this one to make the 7x go first. Well, this is actually negative 7x plus 6 over negative 3. We want to know if these are equivalent. A lot of times, a lot of books do not like to have a negative in the denominator. So what they do is they put the negative in the numerator. To do that, watch. Okay, because remember we learned previously that if there's a negative, it doesn't matter where the negative is, top, bottom, or middle. So if we take the negative out of the bottom and we put it in the top, it's going to look like this. Okay, over 3. And that gives us 7x minus 6 over 3, because we have to distribute that negative, which is the same as this. If you find that a little confusing, there is another way you can look at this. We can multiply the top by negative 1 and the bottom by negative 1, and we would get this answer, because we're multiplying still by 1, a constant of 1. So these are equivalent. So even though they look different, they are not different. So these are equivalent equivalent fractions. All right? Now let's take a look at some problems. All right, let's take a look at some of these. 13y minus 6x equals 11, and these problems are in your workbook, and we're solving this for y. Okay, now here's the deal. We're not going to get an answer like y equals 4 because we have another variable here. So we're going to solve for y in terms of x. Okay, so we're solving this literal equation. Okay, we're solving for y, which means we want to get everything else on the other side. Think of everything else as a constant. So we want 13y here, but we need the 6x out of there. So we're going to add 6x. If we add it to this side, we add it to this side. And we get 13y equals, now it doesn't matter if you write 11 plus 6x or 6x plus 11, doesn't matter. I kind of like the variable first and the true constant last, but that's up to you. Okay, now we have to solve for y, and we're not done because we have a 13 attached to y, so attached by multiplication, so we can divide. Now listen, we could do this. That's fine because every term is the whole side. But what you have to understand is, or we could do this. Either way, watch, the same thing. We could do that, or we can do this, because I can't reduce here anyway, and we get y equals 6x plus 11 over 13. That's probably what your textbook is going to have as your answer, or the e-book's going to have as the answer. Or you can do this, 6 thirteenths x plus 11 thirteenths. It's the same answer. So it doesn't matter if you give us this answer or this one. Both are acceptable. Okay? So that's solving for y in terms of x. We have an answer for y. Y is alone on one side. X is on the other side. Okay. Let's take a look at this one. This is way more fun. You know why this is way more fun? Because we have variables. We're solving for a, and a is on both sides. Here we're solving for y. Y is on one side. I left it alone. Y isn't on this side. I left y there. But here we're solving for a. A is on both sides. Okay, here's the deal. I'm going to subtract 6a. I'm going to work with what I'm solving for first. That's my choice. This is negative 5a minus 2c equals 7d. Lots of letters here. So we're going to be solving for a in terms of c and d. Okay, now I want only things with an a here. So this doesn't have an a, so I'm going to get rid of it. So I'm going to add 2c, add 2c. Negative 5a equals, these are not like terms, So 7D plus 2C. I didn't say 7D. I said 7D plus 2C. Now we're going to divide by negative 5. Divide by negative 5. And we get A equals 7D plus 2C over negative 5. I have to tell you, I don't think you'll see that answer in the ebook or when you go to put it on your answer online for homework, because generally they don't like negatives in the denominator. If it's just a constant term, you'll probably see this answer. A equals negative 7D minus 2C all over 5. Do you see why they're equivalent? Let's think about that. They're equivalent because they took the negative out of here, put the negative in the numerator. But when you put in the numerator, there are two terms there. So they kind of did this. All over 5. They had to distribute the negative. So that's where they got this answer. You can see that. Or, if you're not sure what that's equivalent to, it's equivalent to this. That's a fine answer, but it's equivalent to this. Negative 7/5 D minus 2/5 C. Either one, but I think you'll see this. Okay? So either answer. Okay. Let's take a look at this one. And again, if you have any problems with this or this problem, just ask the instructor in the room. Let's take a look at this one. V equals pi r squared h, and we're solving for h. Okay? All right, if we're solving for h, I'm going to show you how simple this is. We're solving this for h, and notice that we want h alone, and the h is only on one side, so we're not going to move the h over to this side. Okay, but what we're going to do is got to get rid of the pi r squared. The pi r squared is attached by multiplication. All we have to do is divide it out. Watch how simple. Yes, I can do the whole thing at once. Yes, because I have the magic marker. Magic marker. That's not even funny anymore. Okay, so this is v over pi r squared equals h, and we're done. And by the way, that's the volume of a cylinder formula. And now you just solve for the height of the cylinder. Okay? And that's how you solve those three. Okay, we have one more to complete this slide. Let's look at number 4. Okay, we're solving this one for f. There's two ways you can handle this. One way is you can put this over 1, and if you remember, we can solve that as a proportion. But we've actually been doing a lot with our fractional equations, so we can think of this as a fractional equation, and we can multiply both sides by the LCD, which is 9. And we get 9c equals 5f minus 160, because good night 9s. And now this is a lot simpler. We're solving this for f. This is the only f in the problem. I would leave it there. Okay? So that means everything else has got to go to the left. And we get 9c plus 160 equals 5f. Well, now I have to divide by 5. And I get 9, well, or even if we did it once, like we did before, either way, if we did it once, but it's the same, going to give me the same answer. I could leave it like that. Watch. I could leave this answer like this. 9c plus 160 over 5 equals f. I could leave it like that. I can't put the 5 into the 160 without dealing with the 9, or I can do this. 9/5 c plus 160 over 5 equals f, but of course I'd have to reduce this now. 9/5 c plus 5 into 160 goes 5, 10, 15, 3, 32 times. And that's actually how you solve for Fahrenheit given Celsius. That's what we did yesterday, in the last lesson. Or maybe 2 lessons ago, can't remember. But either answer, oh, not that one. Sorry, not this one, guys. That's how we got it. But either this one or this one is okay. All right, just make sure when you do this, make sure you just don't take the 5 into the 160, because don't forget about the 9. The 9 gets really upset if you don't deal with him as well. Okay, and that's it. That's how you solve literal equations. Just get what you're solving for on one side, everything else on the other. That's it. All right, these are you're going to try. These are in your workbook, and on the slide there are 4 of them. There's one more that I couldn't fit on the board right now, but go to your workbook, stop the video, go to your workbook. Please try to attempt this. Don't just keep the video going, okay, and then we'll come back and check them for you. All right, here we go. Number 1, let's see how you did. This was almost like number 1 on the last slide. Okay, 3x plus 5y equals 9. We're solving for x. Okay, x is on one side. I'm not going to touch the x. I'm going to write this so I have some room. All right, now I got to have only the x's on this side, so I got to get rid of the 5y. So I subtract 5y, subtract 5y. However you want to write this is up to you. 9 minus 5y or negative 5y plus 9. Again, you probably know that I'm going to do this, right? And now we're going to divide by 3 to get the x alone. And we get x equals negative 5y plus 9 over 3. You cannot reduce the 3 and a 9 because the 5 will get mad, okay? The negative 5 will get mad. You can leave it like that, or you can leave it like this. Either answer I will take and be very proud of. Oh, I'm getting lower. X equals negative 5/3 y plus 3. So either this answer or this answer is fine. Okay? Hope you did okay with that one. All right, let's try this one. Y equals mx plus b. I'm not going to tell you what this is, but guess what? That m does stand for slope. I'm not going to tell you what that stands for. Okay? You'll see this later on in Mod 13 again, but we're solving for m. Okay, so we're going to have another formula for slope, actually, that you probably will never see again, but whatever. Okay, we're solving for m. M is alone on the right side, so I'm not going to touch him. I want only terms with m here. This doesn't have an m, so I'm going to get rid of him. We get y minus b equals mx. We're solving for m, so we want m to stay, but we need the x to go. This is attached by multiplication, so we have to divide by x. We have to divide by x. Y minus b over x equals m. You could write it as yx minus bx equals m, but because they're all letters, that's kind of weird. Okay, so this is probably what you'll see as the answer. This is solving for m in terms of y, b, and x. Wow. Okay, so that's number 2. Ready for number 3? Number 3 is easier than it looks. Number 3 is actually one way you can discuss the perimeter of a triangle. You just add up all the sides, A, B, and C. I don't really use a lot of formulas for perimeter because perimeter means you just add up all the sides, so why use a formula? But here we go. We're solving for B, okay? That means we need to get A and C out of here, okay? Well, I can do this in one shot if I want to. I can subtract A and I can subtract C. Subtract A, subtract C. And I get P minus A minus C equals B. That was glorious. Okay. All right, last problem. Here we go. A equals 1/2. 1/2 the base times the height. Yes, this is the area of a triangle. I'll tell you what you don't want to do. I know you need to get rid of the h and the 1/2, but if you divide by that, then you're going to have a fraction within a fraction. We don't want that. Okay. What we do want to do is we want to clear this fraction. So let's talk about that a little bit. Treat this as just your typical fractional equation, and this is one whole side. It's one term because it's 3 factors, one term. So we're going to multiply this by 2 and this whole side by 2. So here's what you really have. You have 2a equals. Now remember, these are 1, 2, 3, now 4 factors. You multiply any 2 first. Well, obviously I'm going to multiply these 2 first because that'll get rid of my fraction. That was the goal. So here we just have BH. So 2a equals BH. We're solving for B, so we want the B alone here. Okay, to get the B alone, we have to divide because it's attached by multiplication. Divide by H. And we get 2a over H equals B. We are done. Awesome problem. That takes care of little equations. I don't really think they're that difficult. And now we're on to lesson 8.